Welcome to Ask and Learn.
Hello and welcome to this video solution of numerate. Here we are given a spring mass system where a force F is acting on the mass. So let me write down the given parameters. So we have K, the spring constant, equal to 100 Newton per meter, right? And we have got the mass M equal to 1 kg and the force acting on it F equal to 10 newtons. Part A. Here we have to calculate the amount of compression in the spring. So it is pretty clear from the spring, the spring equation we have F equal to Kx, right? The force is 10 that is given, and here K equal to 100 x, right? So here we have x equal to 0.1 meters. So this is the compression in the spring. Part B. Here you have to calculate the sum of the potential and kinetic energy of the system. So E equal to, the potential energy in the spring is half kx square, and the kinetic energy of the mass is half mv square. Here we have half times k is 100 times 0.1 squared plus half, the mass is equal to 1 kgs, and the velocity is given as 2 meters per second. So 2 square, right? If you calculate this, you will get 2.5 joules. This is part B. Next, part C. Time period t equal to 2 pi root over of m by k. This is equal to 2 pi. The mass is 1 and k is 100, right? Seconds. So this is equal to pi by 5 seconds. Part D. You have to calculate the amplitude of motion, right? So here we can say the total energy is conserved. Okay, that means let's say we take the amplitude as A. Fine. This means in extreme position, the compression of the spring is equal to, so let's say delta x equal to A plus x, right? Now we actually start with the conservation of energy. So we have the total energy stored, right, at the extreme end. It will be in form of potential, which is equal to half k a square, right? Actually half a plus x whole squared, right? Now this will be equal to this energy E, that is due to the compression and due to the velocity, right? So here we have E plus the amount of work done by the force, so F dot x, right? Now we can say that half k a we need to calculate plus x we know. X is the compression, which is 0.1 whole squared. Here E is 2.5. The force is 10 newtons times 0.1, right? Okay, and here we have k equal to 100. Actually this x will be, this is actually A, right? Because due to this force the body moved full amplitude. So this is A. This gives us 50 a square plus 10x plus zero point 0.5 equal to 2.5 plus 10x, sorry, 10a. Right. Now solving this quadratic equation, you will get x equal to, a equal to, the amplitude a equal to 0.2 meters. So this is the solution of part D. Next we have part E. Now you have to calculate the potential energy at the extreme end. So PE, we have already written down the expression half k x plus a whole square, right? Now you plug in the values, the initial values, you will get this equal to 4.5 joules. If we have the potential energy at the right extreme end is given as, so obviously because at the right end we have the force, right? So here we have half k x plus a whole square minus f times of 2a, because 2a is the distance between two extremes, right? So this gives us, if you calculate, this will be equal to 0.5 joules. Now we have to tell that we see from this that the different values in the part B, E, and F do not violate law of conservation of energy, as work done by the external force is there is work done by the external force. That force is equal to 10 newtons, right? So that doesn't violate the conservation of energy. I hope this is clear to you, and have a very good rest of the day. Thank you.